Hello everyone, today we're going to be going over the January 2024 Algebra 1 Regents exam. In our last video, we went over part 1, which was the first 24 multiple choice questions. Today we're going to be going over part 2, which is the free response or the short answer section. This specifically, it's going to be 8 free response questions or 8 short answer questions. For this test, you're required to have a graphing calculator on hand, so I'm going to be using a TI-84 plus CE to solve these problems. And of course, we're going to be starting off with number 25, which tells us that students' scores on a recent test are shown in a table below. On the number line below, create a dot plot to model the data, right? So what is a dot plot? A dot plot is a way of modeling data on a number line where each dot that you draw or each little point that you draw on the number line represents the amount of times that that point of data appeared in your set. Okay, that's a lot of words. What does that mean? All this means is that every single time you see a number on your number line, for example, 85. Let's see, 85 happens 1, 2, 3, 4. 85 happened 4 times in my data set. There are 4 times where 85 appears. That means that on my number line, I'm going to put 4 dots above 85. Right? So a dot plot pretty much represents frequency of data. So 85 happened 4 times, right? So the frequency of 85 in this data set is 4. So I'm going to put 4 dots to represent how many times I saw 85. And I'm going to do the same thing with all these other numbers. So 82, I saw 82 one time. And I saw 82 a second time, right? So 82 has a frequency of 2, right? 2 of these data points are 82. So I'm going to put where this is 81, this is 82, so I'm going to put 2 dots up here, right? And I'm pretty much going to do this for every single point of data. I'm going to count how many times I see it in my data set, and then I'm going to write that many dots where I see the number on the number line. So 85, I just said, happened 4 times. 86 happens, how many times? No times. 87 happens 1, 2, so 2 times, so 1, 2. 88 happens 1, 2, so 2 times, so 1, 2. 89 doesn't happen. 90 does happen. 90 happens 1, 2, 3 times, so there's 3 instances of 90. I put 3 dots up there. Then 92 happens 1, 2, 3 times, so 92 goes 1, 2, 3 times up, right? 95 happens 1 time, so I put 1 dot for 95, and finally 96 happens 1, 2, 3 times, so I go and I plot 3 dots above 96, right? So now what we have to do is calculate the median. And you would be asking, what is a median? A median is just the middle value of a data set, right? So pretty much it's the middle value, the value that's directly in the center when you arrange the data set from least to greatest. So for example, if I have the data set 1, 3, 4, 5, 2, right? Say I have this data set. What I'm going to have to do to find the median is I'm going to have to arrange these from least to greatest. So my least number is 1. The second one is 2, 3, 4, 5, right? So all I did here was I arranged these numbers, these 5 numbers, right, from least to greatest. So 1 is least, 5 is greatest. Next, what I have to do is I just have to find the middle value. What's the number that's in the middle here? Well, how can we do this? We can eyeball it and say that it's 3, or we can cross out numbers on both sides until we're left with 1 in the middle. So I can cross out one number on both sides, 2 numbers on both sides, and 3 is left in the middle, right? So 3 is the median for this data set. So they're pretty much asking us to do that with this data set up top. So I'm going to go ahead and I'm going to write out my data from least to greatest, and I'm going to do that. So I'm going to start by writing 82 2 times. So 82, 82, 85 4 times. So 85, 85, 85, 85, 87, 87, 88, 88, 90 3 times. So 90, 90, and 90. 92 3 times. So 92, 92, 92, 95. And 96 3 times. Cool. So now that I have all my data from in least to greatest order, I'm going to just cross out an equal number of data on an equal number of numbers on both sides until I'm left with 1 in the middle, right? So I'm going to go 1, 2, 3, and I'm going to go 1, 2, 3. Then I'm going to cross out another 3. 1, 2, 3, 1, 2, 3. I'm going to do it again. 1, 2, 3, 1, 2, 3. Now I'm left with 2 numbers, and you may be asking, well, what do you have to do if you have 2 numbers left, right? you can't just cross both of them out because you have no numbers left. So this happens when you have an even number of data. In our data set 1, 2, 3, 4, 5, there's 5 numbers, which is odd, so there's always going to be a middle. But if our data had an even amount of numbers, for example, the data set 1, 2, 3, 4, right, you're left with the same situation where you have 2 numbers in the middle, not 1. All you have to do here is just add those 2 numbers and divide it by 2. And then you get 2.5 as the median for this data set. And that kind of makes sense because what's directly in between 2 and 3? 2.5, right? Because you go a half here and a half here to 2.5. So all that means is that in order to find the median here, all you have to do is just add 88 plus 90 and divide it by 2. And this is equal to 89. So the median of this data set is going to be 89. Moving on to number 26, it asks us to state whether 2 root 3 plus 6 is rational or irrational. So what is a rational and an irrational number? Well, a irrational number is a number that is non-repeating and non-terminating, right? It's a number that has a non-repeating and non-terminating decimal that cannot be converted into a fraction. So for example, pi is an irrational number because 3.141519, and it goes on so on and so forth. There's no pattern that these numbers do. It's not like they repeat forever and ever and ever, right? There's no end to pi. Pi will always keep on going further and further and further, but these numbers, they don't follow a pattern. They don't repeat. Each number after is going to be different than the number before, right? So pi would be irrational because it's non-terminating, it goes on forever, and non-repeating, and you cannot express pi as a fraction, right? 0.33333 is rational because you can express this as 1/3, right? Even though this is non-terminating, this is a non-terminating decimal, it is repeating, right? And because it's repeating, it is rational. Why is it repeating? Because you have a 3 at the end. And it can be converted into a fraction, which means that it is rational. So let's see if this is non-repeating, if this has a non-repeating decimal, and non-terminating decimal. So if it has a non-repeating decimal, a non-terminating decimal that is non-repeating and can't be turned into a fraction, then it is irrational. But if if it gives us just a whole number, we know it's rational. If we give us a number that's repeating, a number whose decimal is repeating, like 0.33333, then we know it's rational. And if we can convert this into a fraction, then we also know it's rational, right? So let's test it out. We're going to go into our T84. We're going to do 2 root 3 plus 6. And we're going to get this crazy number, right? So this is non-terminating. It goes on forever. Otherwise, there would be an end to this number on the calculator. And it's non-repeating, right? The 464101615. This goes on forever, right? But let's see if it can be turned into a fraction. If we go alpha y equals fraction, it converts fraction to decimal or decimal to fraction, and you see that it cannot be converted into a fraction. So now all we have to write to prove this is 2 root 3 plus 6 yields, or is equal to, and I wrote this number down on a piece of paper, is equal to 9.464101615, which is which has a non-terminating and non-repeating decimal. 2 root 3 plus 6 cannot be converted into a fraction. When calculated. And thus must be irrational. Right? So we said that it has a non-repeating and non-terminating decimal, right? That cannot be converted into a fraction. And because this cannot be converted into a fraction, it's non-repeating and non-terminating, it has to be irrational. Moving on to number 27, it says the table below shows data for a recent car trip for the Burke family. State the average rate of change for the distance traveled between hours 2 and 4 and include proper units or appropriate units, right? So average rate of change, I just going to ask you to find the slope between 2 points. And the way that you read this table is this is an x value and this is a y output, right? An x input and a y output. So really you have the point 1 comma 45 if you were to graph this because of this table, right? So they're asking you to find the average rate of change between hours 2 and 4. So they're asking you to find the slope between 2 and 4, right? Now, well, what's the point? Well, here, you know that your x is 2, your y is 112. So you have the point 2 comma 112. And you have here your x is 4 and your y is 238, right? So you're finding the slope between 2, 112 and 4, 238. So what's the formula to find the slope between 2 points? It's y2 minus y1 over x2 minus x1. So plug that into this formula. We have 238 minus 112 divided by 4 minus 2. And if we plug this into our calculator, I'll do that right now. 238 minus 112 divided by 2, it gives you 63. So the average rate of change is going to equal to 63. The slope between these 2 points is 63. Well, you can't just write down 63 because it asks you to include appropriate units. Well, can you find out the units? Look at the units that they give you in the table. You know your y is miles from home, so your y has to deal with miles. And your x is hours after leaving, so your x has to deal with hours, right? So attached to each one of these numbers is going to be 238 miles minus 112 miles divided by 4 hours minus 2 hours. So your answer is going to have units that is miles over hours, which is the same thing as saying miles per hour, or mph. Same thing. Moving on to number 28, it says, on the set of axes below, graph the equation 3y plus 2x is equal to 15. So in order to graph this, all you need to do is convert it into y equals mx plus b, or point slope form, right? How do you do that? Just solve for y. So to solve for y, I'm going to move everything to one side. So I'm going to subtract by 2x on both sides, right? And I get 3y is equal to 15 minus 2x. Then I'm going to divide by 3 on both sides, and I get y is equal to 5 minus 2/3 x. Now I'm just going to put this into my graphing calculator, and I'm going to copy the graph that I see here onto here. So 5 minus 2/3 x. So 5 minus 2 over 3 x, and you want to graph this, right? So your graph is going to look something like that, but you can't really make anything out. On the Regents, you need to plot some points and then draw a straight line through them. This is a linear function, so all you need to do here is really just plot 2 points and draw a straight line through those 2 points. But to play it extra safe on the exam, I would plot all points that fit on my graph. So how do I find the points? By plugging it into my calculator. Well, you go into second table and it gives you the points on the graph. So here it says when x is 0, y is 5. So my first point is going to be 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. That's my first point, 0, 5. Now, when you look at a table, I generally, it's nice to plot points that are in whole numbers. You don't want to plot 1, 13 over 3 because there's no 13 over 3 here. Each grid is 1. So this is 1, 2, 3, 4, 5. You don't want to plot something in between like 1 and 3. You want to plot something at these points, right? These corners down here. Which means that you need to plot points that are whole numbers, like 3, 3, right? So 1, 2, 3, 1, 2, 3. And the points, for example, 6, 1. So 1, 2, 3, 4, 5, 6, 1. And then the point, this point right here. And you could also just go down 2 and across 3, right? So here we're going to go 3 and then 2, 3, and then 1, 2. So now I have all my points graphed out, right? So it's always going to follow that pattern, and you could cross-reference with your table, but I plotted it out. And now all you have to do is just draw a straight line that passes through all of these points. That's a really bad straight line. On the actual test, you're given a straight edge ruler, so I would use that. Make sure your line is straight. Make sure it crosses each one of these points. My graph is incorrect because this line does not pass through this point. You just want, it's really hard to do on a drawing tablet. I'm so sorry, but you just need a straight line that passes through each point that you plotted. So that would probably get credit, right? And then this, don't forget, this has another part. There's another part to it. And it says, explain why negative 6 comma 9 is a solution to the equation. Is negative 6 comma 9 a solution to the equation? Where is negative 6 comma 9? Well, let's find it out. Negative 6 is 1, 2, 3, 4, 5, 6. And 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 6 comma 9 is this point right here. And this has to be a solution to the equation because it lies on the line. So negative 6 comma 9 is a solution to the equation because it lies on the line that you get when you graph 3y plus 2x is equal to 15. Right, so because the point is on the line, it has to be a solution. Pretty much when they ask you for a solution for the graph, it's any single point that lies on this line that you just drew. Cool. So if it's a point on the line, it's a solution. Number 29 says, using the quadratic formula, solve 3x squared minus 2x minus 6 is equal to 0 for all values of x, and then round your answers to the nearest hundredth, right? So what is the quadratic formula? The quadratic formula is negative b plus minus radical b squared minus 4ac divided by 2a. This is just something that you need to remember for the test. I don't really have a pneumatic or anything mnemonic to help you remember, but you just need to come into the test with that in your brain, right? So what is A, what is B, what is C? Your A, B's, and C's depend on the quadratic, not quadratic equation, but your polynomial, right? So your A is always going to be the coefficient behind in front of the x squared. Your B is going to be the coefficient in front of the regular x, the x that is not being squared. And your C is just going to be the number that has no x attached, right? So it goes in alphabetical order from left to right. That's how I would remember it. A is all the way on the left. B is all the way, C is all the way on the right. So what's all the way on the left? 3. What's all the way on the right? C. B is in the middle. Okay, cool. So knowing this, what are our A's, B's, and C's? Well, we know that our A has to equal to 3. Our B has to equal to negative 2, and our C is equal to negative 6. Do not get confused. Always include the sign. If this was 3x squared plus 2x, then your B would be 2. But because it's 3x squared minus 2x, your B is minus 2. So always include the sign with your variable A, B, and C. Right? So now all you have to do is plug this into your equation. So negative B, so negative 2 is positive 2. So you get positive 2 plus minus radical negative 2 squared, which is 4, right? Minus 4 times A, which is 3, and C, which is negative 6, divided by 2A, so 2 times 3. Cool. So that's 2 plus minus radical 4 minus. So what is 4 times 3 times negative 6? 4 times 3 is 12, and 12 times negative 6 is negative 72. So you have 4 minus negative 72 divided by 2 times 3, which is 6. And we can continue working this down. That's 2 plus minus radical 80. Sorry, 2 plus minus radical 76 divided by 6. And this is going to give you 2 answers because of this plus minus. Whenever you see a plus minus, that means that one of your answers is going to have a plus in front of it. The other is going to have a minus in front of it. So this turns into 2 plus radical 76 over 6 and 2 minus radical 76 over 6. Okay, and now to solve this, all you need to do is just plug these 2 points into your calculator. So what's 2 plus radical 76 over 6? 1.786, right? So this x has to equal to 1.786. But notice that they're asking you to round your answer to the nearest hundredth, right? So this is the tens and this is the hundredths place. So you're rounding up. So because this number is greater than 5, you need to round up. So this 8 turns into a 9. And then you need to put in the second point, which is 2 minus root 76. So I'll scroll up, and instead of typing this all out, I'm just going to replace this plus with a minus. And you get negative 1.19 So you need to round to this place because this is a 9, this turns into negative 1.12. So negative 1.12. Those two are going to be your answers. So moving on to number 30, it says the piecewise function f of x is given below. So it says f of x is equal to 2x minus 3 when x is greater than 3, and f of x is equal to negative x squared plus 15 when x is less than or equal to 3, right? So we need to find this and we need to justify our answer. Cool. So what is a piecewise function? A piecewise function, it pretty much is two functions combined into one, right? And it pretty much gives you instructions on how to graph this. It says that when x is greater than 3, so here any point that is to the right of 3, you need to follow this linear equation, 2x minus 3, whatever that looks like. But anything that's 3 or before 3, you follow this quadratic equation, right? You follow this negative x squared plus 15, right? So then you have this curve here. So imagine that you are reading an instruction manual, right? And it says is that, and pages 1, 2 have a separate instructions, and pages 3, 4, 5, 6 have separate instructions. When you're on pages 1 and 2, aka pages that are less than, sorry, wait. So let's say you have this instruction manual, right? And it has 6 pages, pages 1, 2, 3, 4, 5, and 6. The instruction manual, as you flip through, tells you to do this for pages, for any page less than 3 and 3, right? So for pages 1 to 3, 1 through 3, you're using the equation negative x squared plus 15. But for any pages that are greater than 3, it gives you a new equation to use. It says, wait, you're now this far along the graph, or this far along your project. So for anything greater than 3, I want you to use the equation 2x minus 3, right? So here, so just imagine it's an instruction manual that's telling you to switch equations or switch steps depending on the page, and the page is your x, right? So when it asks you to state the value of f of 3, it's asking you to do the instructions, follow the instructions on page 3. And you know that 3 is greater than or equal to 3 because 3 is equal to 3, right? 3 is less than or equal to 3. So is 3 greater than 3? No, this is false when you plug in 3 for x. So you do not follow this top equation, you follow the bottom equation. So you have negative x squared plus 15, and you plug in 3. So negative 3 squared plus 15 is going to be negative 9 plus 15, which is going to be 6, right? So f of 3 is equal to 6 because negative 3 squared plus 15 is equal to 6. That's all you need to write to justify this. And that's all, right? So just remember that when you're doing a piecewise function and they're asking you to solve for a specific point, plug in that point for x into both and see which one is true. What I mean by that is I want you to plug this point into this section first. So first plug x into this and then plug in x into this, right? So when I plug 3 into this, I'm left with 3 is greater than 3 or 3 is less than or equal to 3. Which one of these is true? The bottom one is true. 3 is equal to 3, right? Which is reflected in this sign. So because I know the bottom is true, when I plug it into the second step or the second part of this, the second half, I only plug it into the bottom one or the equation in which my first condition was true. So because the bottom one was true, I then plug it into this. So now number 31 asks you to express the equation x squared minus 8x is equal to negative 41 in the form x minus p squared is equal to q. So this is called completing the square. Right? Why is it called completing the square? Because this is a square. Notice the square here. And you also have two things inside of this square. So that's why it's called completing the square. This is the completing the square form, I guess. This is how you know it. So how do you complete the square? You complete the square by getting rid of any non-x values on one side. So here they already did it for us. Here we have x squared and x, right? Now we need to add a number that allows us to transform x squared minus 8x into a perfect square, like this one up here. So how do we do that? There's a formula that we use. We do b over 2 squared. Right? So remember how we use the quadratic formula, we said that our a is always to the left and our c is always to the right. Here our a is going to be 1 and our b is going to be the value in the middle. So negative 8. So b is equal to negative 8. Negative 8 over 2 is going to give you negative 4, and negative 4 squared is equal to 16. So now, following completing the square, we need to add 16 to both sides. So we add 16 to both sides, and we have x squared minus 8x plus 16 is equal to negative 25. Okay? Now, because it's in this form, we can factor this out. And we end up factoring it out into x minus 4 squared is equal to negative 25. That's going to be our answer. So all we did here was we added a magic number to the end of 8x that allows us to factor this out into x minus 4 squared, right? So we just completed the square. So now it says factor 36 minus 4x squared completely. Whenever you want to factor, you want to see what you can divide both sides by first. So I notice that I have a 36 here and I have a 4 here, right? So I look at my coefficients first. I notice that what do 36 and 4 have in common? They can both be divided by 4 into 9 and 1. So I can factor out 4. And the way that I do it, or the way that I showed that I divided by 4, was I write the number that I divide by outside of a parentheses. And then I write the quotient inside. So if I divide 36 by 4, I have 9. And I subtract that 9 from x squared, because if I divide 4 by 4, I get 1, where it's just 1x squared, just 1, or just x squared, right? So now I'm left with 4, 9 minus x squared. Now I can factor this out even more because of the form a squared minus b squared is equal to a plus b, a minus b. And this happens only when a and b are both perfect squares. So what is a perfect square? A perfect square is a value that gives you like a whole number when you take the square root of it. For example, 4 is a perfect square because the square root of 4 is just 2. 9 is a perfect square because the square root of 9 is 3, right? And x squared is a perfect square because if you take the square root of x squared, you just get x, right? So because my a and my b are both perfect squares, I can just rewrite it in terms of 9 plus x times 9 minus x. And this is going to be my fully factored out answer. So moving on to part 3, I'll do that in a separate video, but that's all of part 2 completed. I hope you learned something in this video. If you have any questions, please let me know in the comments. Otherwise, please consider subscribing to the channel. It does help make videos in the future. Hope you learned something. Goodbye.